Hello and welcome back. I'm having a great start to my morning. Hope you are too. For today's presentation, we got the fourth part in our five-part series in math. We're going to go over solution percentages, alligations, and flow rates and drip rates. All right, let's begin. So from last time, I asked you to get these solutions down pat. So let's review them real quick. D5W is dextrose 5%, and the 10s and 70, the D stands for dextrose again. So you got 10% dextrose and 70% dextrose. NS stands for normal saline, and the strength of normal saline is 0.9% sodium chloride. So the chemical symbol for sodium is Na, and chloride is Cl. So half of 0.9, so if you take 0.9, divide that by 2, you're going to get half normal saline, and that is 0.45% sodium chloride. Quarter NS, 0.22% sodium chloride. Sterile water for injection, of course, should be 0%. And the new one for today, LR, is a common solution, a common electrolyte solution. It's isotonic, and that stands for lactated Ringer's solution. Solution percentages. So going back to our first lesson, we were able to convert from fractions to decimal to percentages. So solution strengths use the same convention. They use the fraction and they turn it into a percentage. So for us, our numerator will have the units of grams, and our denominator will have units of mLs. So you'll always put grams over mLs. So make sure you're in those units. If you're in kilos, change it to grams. If you're in liters, change it to mLs. So that's the fraction we'll make. Percent. So 15%. Percent just means per 100. So for us, now that we have our numerator units and our denominator units, every time you have a percent, that's going to be 15 grams per 100 ml, since this is per cent, and cent is 100. Conversely, there's going to be 15 grams of diluted solute within a total solution volume of 100 mLs. So anytime you're dealing with 100 ml volumes, it makes the math quite easy. So what's 5% of 100? Well, that's just 5. 10% of 100? 10. 70%, and so on and so forth. 120%, yes. Here we're dealing with densities, but in pharmacy, we're probably not going to deal with too many things that are oversaturated. To find out how much solute is in a given solution, there's two things you'll need to know. You'll need to know the volume and the concentration, in this case in percentage. All you have to do is take the mLs times percent, and that'll give you grams. So for this example, how many grams of solute are there in 250 mLs of a 30% solution? Take the mLs, 250 mLs, and multiply it by the percentage. You can use your percent sign, or conversely convert the percentage into a decimal. Crunch the numbers, you should end up with 75 grams. So within 250 mLs of this solution, that's 30%, you would expect to have 75 grams of diluted solute. Dissolved solute, sorry. Next example, how many grams of sodium chloride are in 1.5 liters of NS? They gave us the volume in liters. We just need to convert that into mLs. 3 spaces to the right. So we have 1500 mLs times the normal saline concentration, which is 0.9%. 13.5 grams of diluted solute in 1.5 liters. Let's try these. So all we have to do is mLs times the percentage. So if your calculator has the percent button, all you have to enter is 100 times 0.9 and push the percent button. You don't have to push the equal in most cases. So here we have a volume of 100, no math needed, 0.9 grams. So if you recognize that, good for you. Number 2, 500 mLs at 5%. So 500 times 5% gives you 25 grams of dextrose. For the third problem, we just have to convert these English units, ounces, into mLs. So 1 ounce for us is 30 mLs, and half NS is 0.45. So 15 mLs will equal 15 ounces will equal 450 mLs. Just multiply that by the strength of half NS. So about 2 grams of salt diluted in 15 ounces of half NS. Okay, now you need to solve for the percent concentration. So it's the same convention as our first lesson, fractions, decimal, and percentages. We're going to create a fraction here, and then that will give us a decimal once we divide grams divided by mLs. And then when you multiply by 100, that gives you your percent. So again, our units need to be in grams and mLs. So if the units aren't in grams and mLs, just convert them quickly. So we got a word problem here. 25 grams of dextrose was added to enough water to make 400 mLs of solution. What is the resulting concentration? So we just got to put our grams over mLs, and our units are already in grams and mLs. Then don't forget to multiply by 100 to get to percentage. So 25 grams and 400 mLs total would yield about 6.25% dextrose. All right, let's try these. So what we have to do is make our fractions. So for number 1, 48 grams over 250. Don't forget to multiply by 100. And you should come out to 19.2%. For number 2, kilos, let's change that to grams real quick. So 3 spaces. So that's 250 grams. And we'll change this to liters as well. 1, 2, 3, 4,500 mLs. Don't forget to multiply by 100 to find your percentage. So about 5.56%. All right, this last one, you probably won't get a question like this on any quizzes or exams, but here I'm just testing out your conversion skills. So we got to change pounds to grams and gallons to mLs. So we have 1 pound per gallon. I converted the pounds to kilos, so I can get that to grams. Next, I converted gallons to mLs. We got 3,840 mLs per gallon. Gallons cancel out. We're left with grams per ml, and that's the units we need. And then don't forget to multiply by 100. So a pound in 2 gallons yields about 5.92% strength solution. Alligations. Alligation is a method where you have 2 supply solutions, and those are the only 2 you can use. You're going to have to combine them in some way to get a different solution. So in this case, we need to combine them and get a 20% solution, and the volume we need to make is 500 mLs. So how many mLs of each solution must we mix together to end up with a total of 500 mLs of 20%? So this is alligation type 1, where you have the final volume given to you. So let's solve this. All right, in alligation type 1, you're given the final amount. So if you look in the order and they tell you to make a specific quantity, then you know that is type 1. So we have our two supplies, 10% and 70%. Our order concentration is 20%, and our total volume is 500 mLs. So we'll need to make 500 mLs total, and the final resulting concentration is 20%. All right, step 1, you want to place the order concentration in the middle. So you just need the percent value. You don't have to convert it to a decimal. So just place 20 in the middle. Next, place the supply concentrations in the upper left and lower left. So we got 70 and 10. I usually put the higher concentration on top and the lower concentration on the bottom, but it doesn't matter as long as you follow the steps through. The next step, find the difference diagonally across. So it's just a difference. No negative numbers here. So 70 and 20, the difference there is 50. And then 10 and 20, the difference there is 10. So those numbers represent parts. So this is 10 parts. And this is going to be 50 parts. So this is just a method to find the volumes of each supply. All right, so what do we have pictorially? So we have the whole amount, which needs to be 500 mLs. And that whole amount needs to be 20% in the end. But what we know is there's going to be 10 parts of one solution. And we know there needs to be 50 parts of another solution. So how many total parts? So there will be 60 total parts. So you can say that 500 mLs must equal 60 parts. All right, so let's add those parts together. So here we're going to make a fraction, 10 out of 60, because it's 10 out of the whole. And the other fraction we'll make is 50 out of 60. Right? So let's draw that picture again. So we got 10 parts here, and we got 50 parts here. All right, so the last thing we need to do is multiply by the final volume, right? Because what's 10 out of 60 times 500? That's going to be 83 mLs. 50 out of 60 times 500, that's going to be 417. So what we got is 83 mLs, and we got 417 mLs. So we know the volumes, but it's very easy to mix up the volumes, mix up the concentrations. So in order to label, just follow the concentration straight across. So here's the 70%. So the 83 mLs goes with the 70%. And the 10% volume will be 417 mLs. So I need to add 10% here, 417 mLs, and 83 mLs of 70%. So that's our proportion. And then if you add these two volumes together, they should end up equaling the final volume. Many steps. Let's do a few more examples, and you just have to follow the steps through. All right, first step. Place the order concentration in the middle. So for us, the order concentration is 5%, D5W. Next, we have two supply concentrations. We got D70, and sterile water, of course, is 0. So we'll put those on the left-hand side, 70 and 0. The next step is to find the difference. So the difference between 70 and 5 is 65. Between 0 and 5 is 5. So how many total parts do we have? So we have 5 parts here, 65 parts here for a total of 70. So 5 out of 70 and 65 out of 70. Last step on a type 1 alligation is to multiply by the final volume. So we'll multiply by 250 for this question. So we'll need 18 mLs of 70%, and we will need 232 mLs of sterile water for injection. So it's very easy to mislabel these volumes, so just be careful when you're entering any homework assignments. Alligation also works with decimals. Let's do this one. The order is 3%. We have a supply of 23.4 sodium chloride, and NS, of course, is 0.9%. Next step, let's find the difference. Here we got 20.4. The difference here is 2.1. We got 2.1 parts, 20.4 parts. So now all we need to do is make our fractions. 2.1 out of 22.5 and 20.4 out of 22.5. Last step in a type 1 alligation where you're given the final amount is to multiply by the final volume. Times 100, we'll need 9.3 mLs of the concentrated sodium chloride, and we'll need about 91 mLs of the normal saline. Altogether, that should give us our final volume, 100 mLs. All right, a variation of the problem is type 2 alligation. Here in type 2, they're asking you to use a specific supply amount. So you're given a starting amount. So notice here, there is no final volume. So that's how you will identify the difference between type 1 and type 2. So what this is saying is we have to start off with 50 mLs of our supply. So we have 50 mLs of 15% solution. Right, and we'll need to add 85% solution, but we don't know how many mLs. And once we add those two together, we should end up with 40%. And we'll need to figure out that final volume. Right? To figure out the final volume, all we had to do is add these two and get the final volume. But let's solve for how much 85% we need. So it's similar to type 1 alligation. We're going to place the concentration in the middle, our supply concentrations to the left. Find the difference. Find the difference. And this is where the similarity ends. Right? So we can still draw a picture to indicate the parts, but we're going to use it a little bit differently. So we have 25 parts and we have 45 parts. How many total parts are there? 70. Right? 70 parts. So what we know for the 15% concentration is that we have to use 50 mLs. So here's the 50%. It equals 45 parts. So this 45 parts must equal a volume of 50 mLs. So here's 45 parts. That's 50 mLs. Right? 45 parts equals 50 mLs. And we know what to do with equalities. That means all we have to do is solve for 25 parts. So the information we got from the question, or doing the alligation, is 45 parts must equal 50 mLs. So here 25 parts equals how many mLs? So this is our conversion factor. 45 parts equals 50 mLs. So now we solve for 25 parts. So just put it over 1, multiply by your conversion factor, and you'll see that for alligation type 2, you're going to need 27.8 mLs. So let's draw this out. So we had 25 parts. We had 45 parts here. We know that this 45 parts must equal 50 mLs. And we just solved that this is about 28 mLs. So the total volume that we can make is 78 mLs. All right, let's try another example. So we put the order in the middle, and then we put our supplies to the left. Find the difference. Here we got 20. 10 and 75 is 65. So what was given? So in type 2, you're given a starting amount, and in this case, it's 100 mLs of 95%. So you got to look for the 95. In this case, it's over here. So these are 65 parts. We know that that must equal 100 mLs. So the 20 parts we'll solve for. 20 parts, multiply by our conversion factor. And we find that for the 10% solution, we'll need to use about 30.8 mLs. So how much total can you make here of 75%? So you add in the starting volume of the 95%, and you add to that the 10% volume. So be very careful on what you enter in as your answer, because the question could ask for how much 90%, 95% did you use? It can ask how much 10% you should use, or the question can ask how much total 75% can you make. So just read each question carefully and answer the question given. On the PTCB exam, you won't have nicely labeled ordered end supply. You'll just have a word problem, and you'll need to figure out what type of problem is it and how to solve it. So let's find the orders in the supply. So how much cream must be added to 2 ounces of 2% hydrocortisone to make a 1.25% hydrocortisone cream? So the order is here. That's going to be the order, because that's what we'll need to make. We have a 2% supply. That's our first supply. And cream is our other supply. That is at 0%, just like sterile water for injection. And our given amount is 2 ounces. So I'll convert that to about 60 grams. All right, let's start the same. Order in the middle, 2 supplies to the left. Let's find the difference. 2 minus 1.25, we got 0.75. And the difference between 0 and 1.25 is 1.25. So the 60 grams, does it go with the 1.25 parts, or does it go with the 0.75 parts? So it's going to go 2 ounces of the 2%. So it's going to go here. That's going to equal to 60 grams. So now all we have to do is solve for 0.75 parts with our conversion factor that we just figured out. And we'll need to add in 36 grams. Flow rate, drip rates. So in the pharmacy, on IV bags, we'll place in the flow rate in the units of mLs per hour. So all you have to do is place the volume and divide it by the hours. So for this example, the doctor orders 1,000 mLs of NS to be infused intravenously over 6 hours. So it tells you what to do mathematically. It says take the 1,000 mLs, put it over 6 hours. And we know if you put something over, you're going to divide. So to the nearest ml, 167 mLs per hour. All right, let's solve these. So remember, you need to be in the units of mLs and hours. If you're not in mLs and hours, just convert to that. So 500 mLs over 6 hours, or fraction. 500 over 6 crunches out to 83 mLs per hour. 2 liters ATC. So this is around the clock, a whole day. So we have 2 liters, which is 2,000 mLs, and around the clock is going to be 24 hours. 2,000 divided by 24, still 83 mLs per hour. And for the last example, 30 minutes. Well, how many hours is that? Yeah, it's just a half hour. So 50 mLs over a half hour. The flow rate's going to be 100 mLs per hour. The patient's only getting 50 mLs, but the rate is 100 mLs per hour. So this is what the pharmacy will place on the label of any IV infusion product. However, the units of flow rate are way too large for the nurse when they're administering the medication. So what they'll do is they'll convert to drips per minute. So as they're adjusting the clamp, they can estimate how many drops enter into the drip chamber, and that would approximate the flow rate. So your drip rate will depend on the type of tubing used. If you use real thick tubing, then the drops will be a lot bigger. If you use small tubing, then the drops will be a lot smaller, and you'll need a lot more drops to get an ml. So micro drip tubing, usually for pediatric administration, we'll use micro drip tubing, but that's always going to be 60 drops per ml, and that's a definition. So you may want to add that to your flashcards. Macro drip tubing is anything besides micro drip tubing, and they will have to give you the value of the drops. So standard 10, probably 10 drops per ml. You can get a little bit bigger, a little bit smaller. And also depending on the viscosity of the IV, it may change the drip rate as well. All right, let's convert. So the first thing you do is you got to find the flow rate. So let's find the flow rate. mLs over hours. First step is to divide by minutes. So we're converting the hours into minutes. And the last step is to multiply by drops. So that's converting the mLs into drops. Take a look at your units. We are left in drops per minute. So 250 mLs over 4 hours is the same as 10 drops per minute. Now the nurse can adjust the clamp and count about 10 drops per minute, and they're set. The IV is set. They'll check it. They'll check the flow rate or the progress probably after an hour or so and adjust if need to. All right, let's try this one. So remember, we need to be in the correct units for flow rate. So we have a liter. We'll need to change that to eventually to mLs. All right, so step one, let's change the time. Divide by 60 minutes. I change the volume to mLs, and then we're going to multiply by the drip factor. In this case, it's 15 drops per ml. Make sure your units cancel out. We're left in drops per minute, and that comes out to about 42 drops per minute. All right, so for this one, the nurse can probably just count over 30 seconds because it's a large enough number. So about 20, 21 drops per 30 seconds, and that one should be okay. All right, very good, everybody. So for next time, please recall these equations. Months over 150 times the adult dose. That's going to be Fry's rule for infants. Pounds over 150 times the adult dose. That's going to be for children. Clark's rule. And lastly, Young's rule. You get their age in years divided by their age in years plus 12 times the adult dose. And of course, if it's in years, that's going to be for children as well, between the ages of 1 and 12. Once again, thank you for joining us. And if this was your first time, there's a whole series. Please go back and view Math 1, 2, and 3. And up next is Math Part 5. Thank you guys, and you guys have a good day. Into Part 4. Please go on to Part 5. Dang! Fong dang!